Uh, Hello students. So today is the first class of the business statistics, and the course code is BADM 221, and today in this video we will discuss about the unit 1 and unit 2, which will describe about the data, statistics, and about the samplings. So, what is statistics? So statistics is an art or science, you can say, that deals with the collection, analysis, interpretation, and presentation of data. So it is all playing with the data. So if you are representing a data, or you can in the form of chart, or concluding about the data, doing the analysis about the data, so that is all called as statistics. Now we can describe the statistics into two parts, descriptive statistics and inferential statistics. So descriptive statistics, which summarizes the data by graphing or by using numbers, like finding the average, finding the median, mode, right? And inferential statistics is all about concluding about the population. So you have an information about a small sample, and from that information you can conclude about the whole population. That is called as a inferential statistics. Now, a few terms we will frequently use in this statistics. It is your first one is population. So population is a collection of all elements. So for example, I can say the whole BC as a population, right? And in the whole BC, Vancouver is a sample, then Prince George is a sample, then Kelowna is a sample, and etc. We can also say the whole Vancouver as a population, and in that whole population, we can assume that New Westminster as a sample, and then Burnaby as a sample, and then Surrey as a sample, and so on. So it can be a collection of all elements which you want to study, and then from that population, so sample is always a subset of population. So small, from that population you would take small parts, and that is called as a sample. Now, the numerical measures which we describe for population, so for example, population mean, population standard deviations, so those are called as parameters. And for samples, so for example, sample mean, sample standard deviation, those are called as a statistic. Now, when we will handle the data, so generally we have to know that which type of data it is. So we can divide the data into two types. One, quantitative data, and the second one is qualitative data. So qualitative data, where you can describe it by words, like color of the t-shirts, or color of the hairs, right? So blood type, so O, A, B, AB positive, and where you can describe the element, whether it is a person or it is a thing. So like color of fruits or types of fruits, apple, orange, banana, and like that. So when you describe, so those are called as categorical data or qualitative data. Quantitative data, which involve numbers. So for example, numbers, it can be anything, height or weight, and number of magazines currently subscribes. But quantitative data, again, we can divide it into two types, like discrete quantitative data and continuous quantitative data. Discrete quantitative data, which we can count. So for example, number of students in a class, number of phone calls, number of fruits, right? So which we can count, number of desks in a class. So any data which we can count, number of employees. So that is called as discrete quantitative data. So generally it will be integer, not in decimal point, whereas continuous is any measures, is any measurable quantity can be called as a continuous quantitative data. For example, height of a person. So it can be 155.1, 155.125, 155.175, and like that. So between 155.1 and 155.2, so there can be n numbers. So all measurable quantity generally comes under this, or all measures which have the decimal points generally comes under this, like height, weight, time, temperature. All these are quantitative continuous data. Now, few words which we will frequently use, and all of you know how to calculate, but just to review that, because we will frequently use these terms in statistics. The first one is mean. So mean is like finding average. So you have the student scores as student 1, student 2, 3, 4, 5, and then you have the numbers. So to find the mean, you will add all the numbers and divide it by number of students, which is 5. So you will get the mean score. The same way, the proportion, it is a ratio, right? So you have in a class, you have 25 male students, 20 female students. You want to know what proportions are female students or what proportion are male students. So what you will calculate is you will find the total number of male students divided by total number of students. So you will get the proportion of male students in that class, and then it is your proportion of female students. So 20 female students divided by total number of students. So it is your proportion of female students in a class. Now, so for calculating about the population, or finding a conclusion about a population, you need to know how the sampling is done, how we can select the samples, and what are the different types of sampling. So the random sampling, the first one, random sampling, where each element in the population has an equal chance of being selected for the sample, right? So you have like 200 numbers in a population, for example, and you want to create a sample of 10 numbers. So now each of these 200 numbers has equal chance of getting selected. Then it is called as a random sampling. Now, if there is some convenience, like maybe few numbers are written more closer to you, it is more closer to you, so more convenient, or we can choose like first 10 numbers, or last 10 numbers, or middle 10 numbers. Write any 10 numbers between 10 to 30, maybe, like that. So which is easy and time saving, and which is based on some biasness. So then that is not called as random sampling, it is called as non-random sampling. So the types of sampling, the first one, as I said, so you have 20 numbers here, different colors of balls, and you have, like, suppose 100 different colors of balls, and you want to select the balls of 10 balls in a sample. So you have the equal chances of all the balls getting selected. So you just close your eyes and just choose 10 balls randomly, and that is your random sampling. Stratified sampling. So you divide the population into groups, right? So you have different color balls, so you divide it in red color balls, and then blue color balls, and then black color balls. And then you choose that, okay, so maybe two from red color, three from blue color, and one from black color. So that is your stratified sampling. So for example, in your whole class, there are students from different countries. So you collect the students, you need to choose 10 students, random 10 students as a sample. And so what you did is, for stratified sampling, is you choose make them groups country wise. So first group from the students from Filipino, and then second group the students from India, third group students from Nepal, fourth group students from Mexico, and so on. And then you choose maybe two from Filipino, two from India, five from Nepal, and three from Mexico. So in that case, all the groups, you make sure that the group contains the students who are from different countries, right? So that's why stratified sampling are used. And cluster sampling. So cluster sampling is, you divide the population into groups, and then randomly select some of the clusters. Like what you do is, suppose in a classroom and different desk, right? So there are different students sitting on different desk. Now you choose, like, okay, so maybe all the students from first desk, and then 10th desk, and then third desk, all students should come here as a sample, right? So that is called cluster sampling. So you divide the groups into, randomly you divide it into clusters which may contain the same number of countries, or if you take the country example, so which may contain the same number of countries or may different number of countries. So maybe cluster of 4 groups, 4 students, 5 students, 6 students, 3 students, and like that, and randomly choose those clusters. So maybe first cluster, fifth cluster, 10th cluster should come as a first sample. So that is called as a cluster sampling. Systematic sampling, so you make a queue or a line of each balls, and then you assign numbers to each balls, and you say that every fourth data should come under the sample, right? So if you are considering the first, so it is every third. So first, if you are considering, so fourth one will be considered, then seventh, and then 10th will be considered. So every nth piece of the data will be selected as a sample. So for example, in a same country wise, you can line up the students for all countries, independent of all countries, you assign each of them a rank, and then you decide that every 10th student should come as a sample, right? If you have 100 students, every 10th student should come as a sample. So you have a sample of 10 students. That is called random sampling. Convenience sampling. Convenience sampling uses readily available results, like suppose you want to do survey, right? So survey about maybe what is the opinion of the current traffic situations in Vancouver, right? So anything it can be. Now you want to know that. So suppose you you stand near to the Burrard station, and you ask whoever is going or passing nearby, and you ask this question, so what is their current opinion? So that is your convenience sampling, because Burrard station is just near to your college, and you are telling, and they might have the opinion like, oh, it's very terrible because they are the people who are near to the downtown, they come every time the downtown, and it is more traffic over there. But when if you are not doing so, maybe you can do the survey. If you are not doing the convenience sampling, so maybe you do the survey for the whole Vancouver different places, and conclude about the traffic situations in Vancouver. So whatever is convenient to do, and if you do the survey of that any under any circumstances, so then that is called as a convenience sampling. Now, based on those sampling definition you have learned, now these are the few questions where you need to identify which sampling is it. So a study was conducted to determine the average tuition that San Jose State undergraduate students pay per semester. Each student in the following samples is asked how much tuition he or she paid for the fall semester. What is the type of sampling in each case? Right, so the first one is a sample of 100 undergraduate San Jose State students is taken by organizing the students' name by classification, freshman, sophomore, junior, or senior, and then selecting 25 students from each. So think about it, and what is the type of sampling here. Okay, so that is your stratified sampling. Second one, a random number generator is used to select a student from the alphabetical listing of all undergraduate students in the fall semester. Starting with that student, every 50th student is chosen until 75 students are included in the sample. So pause the video and think about it. What type of sampling is it? So it is systematic sampling. A completely random method is used to select 75 students. Each undergraduate student in the fall semester has the same probability of being chosen at any stage of the sampling process. So pause the video, think about what type of sampling is it. It is random sampling, simple random sampling. The freshman, sophomore, junior, and senior years are numbered 1, 2, 3, and 4 respectively. A random number generator is used to pick two of those years. All students in those 2 years are in the sample. So pause the video and think about what type of sampling is it. It is cluster sampling. An administrative assistant is asked to stand in front of the library on Wednesday and to ask the first 100 undergraduate students he encounters what they paid for tuition the fall semester. Those 100 students are the sample. So pause the video, think about what type of sampling is it. It is convenience sampling. Now summarizing the data. So summarizing the data, we have three different methods. The first one by calculating the frequencies, second one by calculating the graphs and charts, and the third one by calculating the summary measures. So let's start from the first one, calculating the frequencies. So soft drink purchases are asked to select one among the 5 popular soft drinks: Coca-Cola, Diet Coke, Dr. Pepper, Pepsi, and Sprite. Soft drinks selected by a sample of 20 purchasers are, these are the 20 samples: Now these are the qualitative data, as you can see. So these are described by the brand name, right? So these are not by numbers. So therefore, this is your qualitative data. Now we have to create the frequency. So frequency means how many times that number has appeared, or how many times the same data has appeared. So we have the 5 different brands we can see. So 1, 2, 3, 4, 5. Yes, Coca-Cola, Diet Coke, Dr. Pepper, Pepsi, and Sprite. So we can write down. So those are your X values. So we can write down what are the 5 brands, and frequency means how many times that brand is repeated. So Coca-Cola is the first brand. So how many times Coca-Cola is repeated? So this is the first one. This is the second one. So 2 times, right? So this is your 2. And then Diet Coke. So this is 1 time. And this is second time. This is the third time. So 3 times, and like that you will find for Dr. Pepper, Pepsi, and Sprite, and in total it is 20 times because we have 20 data. Relative frequency describes that out of the total data, how many times Coca-Cola appeared, right? What proportion of the total data, the Coca-Cola is what proportion, right? So 2 over 20, we can calculate this by 2, the number of Coca-Cola divided by total number of data. So we learned the definition of proportions. So the same way we will calculate. So 2 over 20, then 3 over 20, 5 over 20, which is 0.25, and like that we can calculate. So that total relative frequency should be equal to 1. And the percentage frequency, so relative frequency multiplied by 100, so you get the percent frequency, and hence the percent frequency should be equal to in total 100. Now quantitative data, the same example. So we have this 20 clients, we have year and audit time in days. So these are in days. Now, if you see the range of the data, so it starts, the smallest number is 12 and the largest number is 33. And you can see the numbers are not repeated frequently. So you cannot see 12 many times, you cannot see 13 many times, only one time. So in that cases, what we do, we take the interval. So we divide that in interval. So we can count how many data from 10 to 14. Now this can be your choice because here it is divided from 10 to 14. Now you can decide that, okay, because my minimum number is 12 here, so I can start from 12 and then 13, 14, 15. So until 15. So 12 to 15 you can count, and then you can count 15 to 18, 15, 16, 17, 18. The interval should be same throughout, and you can count how many data in that interval, right? So like here 10 to 14, there are 4, 15 to 19, 8, 20 to 24, 5, 25 to 29, 2, and 30 to 34, 1. Now you can do 12 to 15, then 16 to 19, and like that. So intervals should be the same. If you are taking the interval of 3, then 3, in interval of 5, then 5. You can write down how many data are there so that total number will not change. So your total frequency will be always 20. Now relative frequency, the same way, how many times it is repeated out of the total times. So 4 over 20, you can calculate what is the relative frequency. 8 over 20, it is 0.4, and so that always the total relative frequency will be equal to 1, and hence the percentage frequency will be equal to 100%. Right, so another one is cumulative relative frequency. So cumulative relative frequency is the addition of all the previous relative frequencies. So for example, for this one, it is addition of all previous, so there is no previous, so it is 0.2, only 0.2. Now for the second one, it is addition of the current one and the previous one, so 0.4 plus 0.2, so which is 0.6. And for this one, 0.85, it is 0.25, 0.4, 0.2, so addition of all these three. And for the fourth one, addition of fourth and the previous all. Fifth one, so fifth plus all. So that because it is addition of all this one, so cumulative frequency, the last data will be always equal to 1. So same way you can calculate for this data what is the relative frequency, just for your exercise. So what is the relative frequency and what is the cumulative relative frequency, the same way as the previous example. Now the second way of representing the data is through graph and charts. The first one is a pie chart. So pie chart, as you know, so it is described as a pie of a circle, so different pie will represent the different data. So we have a data already we learned based on the different Coca-Cola, different brands of soft drinks. So the same data we represented here. So we could calculate that Dr. Pepper is 25%, Pepsi is 45%, and Sprite is 5%, Coca-Cola and Diet Coke is 15%. And this way, this gives you the good visualization. So charts and graphs always give you the better visualization of a given data, and you can just see this graph and decide that, okay, Pepsi is the most frequent, right? You no need to see the numbers, and you can easily see the Pepsi is most frequent soft drink what people purchase. So bar chart is another way of representing, and here also you can select the data in Excel, both the data, and press insert and press the column chart. Column chart, generally it is described as a bar chart, and you will get the graph, and then you can edit this one. So separate videos are attached to in the Moodle for how you can create the pie chart or bar chart or any other kind of graph in the Excel, so to give you an idea. So basically bar chart also will create a visualization that how the data is represented in the form of bars. So after seeing this bar chart, also clearly you can see that Pepsi is the most purchased soft drinks, right? So you no need to see the numbers. Now bars can be vertical or horizontal. So there are two types of column graph. So it can be this graphs can be the horizontal one, that is sleeping bars, if you change the X and Y axis. So if you change the X and Y axis, the bars also change. Pareto chart. So Pareto chart generally represents, it is a special type of bar graph which represents the data in sorted order. So that is in from largest to smallest, that is descending order. So it will give you the pictures that most, then second most, and then continuously to the least. So Pepsi is the most purchased, then next is Dr. Pepper, then Diet Coke, Coca-Cola, and then Sprite. Stem and leaf graph. So this is the another way of representing the graphs. It doesn't include any visualization, but it helps when there is a large number of data with the same numbers. First two numbers same, and you have a large set of data. So stem leaf representation helps you in order or organizing the data. So how we can represent it as this one. So suppose you have this data here, and you can see the first two numbers here are almost same. So what we can do, so the first two numbers describes you the stem, and the last number represents the leaf. So you can say that 23 is the first number, 24, 25, and 27. 26 you can say, and 27. So you have the stem as this one. So for 23 you have two last numbers, 0 and 4. So you write the leaf as 0 and 4. Then 24, two leaf and one leaf, that is 5 and 2. So 2 and 5. Then 25, one leaf, that is 6 and 1. So 1 and 6, and 27 2. So there is no leaf for 26, so you can leave it blank. Right, and the same way for this example you can say that these are the numbers. So you can see 2, 3, 4, 5, 6, 7, 8 till 8 you can write, whereas 5, 6, 7 is not there. And then after decimal point you can write the numbers which is repeated. So leaf, it is 2.0, 2.4 and 2.5 are there, so you can write as the leaf as 0, 4, 5. And same for 3, that is 1, 1, and then 2, and then here it is 6, and then here it is 8. Right, so like that for 4, 6 and 7. 5, 6, 7 no data is there, and the last one is 8.1, so 8 and then 1. Histogram, so it is another type of bar chart where the data is represented in terms of intervals. So if you have data within an interval, so generally there will be no gaps within the interval. So if you have a data of this kind, so you can see 59.95, 61.95, and then again 61.95 to 63.95. So this data is included here. So if this data is not included here, and it is generally for continuous data, if it is not, so it is the same as your bar graph. But if it is the same number here, so then it is your histogram. So there is no gaps between the two intervals, right? And then you can just plot the bar graph with no gaps, then it is your histogram. Right, and the last part, how we represent the data, it is through summary measures. Now, in summary measures, we do it into four types of descriptive measures, so which helps to describe a set of numerical data. Right, so location, center, skewness, and spread. So all these data we will all these types we will first describe here, and then you need to see the Excel, how we can do it using Excel. So the separate Excel video is there for solving this using Excel. Or we can do parallelly as well. So I will show you both. Yeah. So the first one, location, that is quartiles, calculating the quartiles and percentiles. So quartiles basically is when you divide the whole data into 4 parts. So the first quartile, second quartile, third quartile, and fourth quartile, right? So you divide the whole data into 4 parts. Now I will come directly to here. So you have this data set, for example. So you have, I guess, how many data? So 2, 4, 6, 8, and 10, 12 and 14 data, and you need to find the 4 quartiles, that is Q1, Q2, Q3, Q4, 4 parts. Now, the first we will find always the second quartile if you are doing it manually. So I will show you how to do it in Excel as well. So the second quartile will be the middle one because we have a 14 data set. So therefore, we will choose the middle two and take the average of that. So middle two is, this is the middle one. So middle two is 6.8 and 7.2. So the average of these two is your 7. So we got the second quartile. And so this one divides the whole data into 2 parts. This is the first part and this is the second part. And then you can calculate what is the middle of this one. So middle of this is your first quartile and this is your third quartile. Middle of the second half is the third quartile. So you have Q1, Q2 and Q3. So middle 3 parts. And then minimum and maximum. So minimum is your 1, maximum is your 11.5. To find the quartiles, always remember the data has to be sorted. If it is not sorted, so always it has to be arranged first in increasing order and then only you need to find the quartiles. Now the next one is interquartile range. So interquartile range, so that is the middle half or middle 50% of the data, so which is given by Q3 minus Q1. So Q3 minus Q1, that is 9 minus 2, we got that as 7. And to find whether there are any outliers. So what is outliers? That is the extreme values which is not following in the pattern. So suppose all the data is between 1 and 10, but one data is your 85 or one data is your negative. So that is an outlier, but whether that data will be considered as an outlier or not mathematically, you can find out using this relation. So what the formula here is if it is less than 1.5 quartile below the first quartile. So you will find what is Q1 minus 1.5 times IQR. And you will find what is Q3 plus 1.5 times IQR. Right. So if the value is between these two values, so then this is your not an outlier. If it is outside these values, this range, so this will give you the lowest value of the range. This is will give you the highest value of the range. And if the value is in between these two values, so then this is your not an outlier. If it is outside, then it is an outlier. Okay, so let's go to the next one. So we have 2, that is Q1 minus 1.5 times IQR, which is this one, and 9 plus 1.5 times 7, which is 19.5. Now this is a lower range, this is a higher range, and we can see no data is outside this 2 range. So therefore no outliers in the data set. Right, so these are the 5-number summary. So you can divide the whole data into 5 parts. That is, this is your minimum and this is your maximum. right? And you can divide this into 4 parts, that is 1, 2, and 3. So I said earlier 4 parts, so this is the fourth one actually, which is the maximum. So Q1, Q2, and Q3. And this is the 4 parts, 1, 2, 3, 4. Right, so this is your the 5-number summary. So if it is asked that in this following data set, calculate the 5-number summary, that means you need to find the minimum, you need to find the maximum, you need to find Q1, Q2, and Q3. Now let's see how to do this in Excel. Okay, so we have this one. We have the data set here and we want to find the minimum. So we will write minimum here and we can calculate we need to find, I will just write first what we are going to calculate. Q1, Q2, and then Q3, then maximum. So we want to find this 5. So this is equal to minimum. To find the minimum, you need to press equal to minimum and select the whole data set. We can easily see the minimum is 1. So if we press, it should show as 1. So press it and it will show 1. Now to find the quartile is equal to quartile dot exe. And you will select the array. It is showing the formula as well. So you will select the array and then quartile. So array is this one. So you will select the whole and then 1 as your quartile. And is equal to second quartile is equal to same quartile. Array, select the array and then 2. Close the bracket. Press enter. So second quartile is equal to quartile and we will select the whole array and press 3. So this is the third quartile. So third quartile, because it is numbers, so we can reduce it the numbers. So we will get the number exactly is equal to max and then open bracket, select the whole array and close bracket. So press enter. So we have the maximum value as well. So these are the 5 quartiles, 5-number summary. And for assignment, you need to know that how to do it in Excel. So practice it in Excel and we will have a demo class on the week when we will do it in person. Also, if we want to represent this in the form of box plot, in the form of graph, so you can select this whole data first and then press insert and go to the charts, all charts, and then box and whisker, and you can create. So this represents the 5-point summary. So you can see this line here. 1 second. If you see, this is the line, this shows the minimum. This is your Q1 2. This is your Q2 7. Q3, which is 9, and this is your maximum. Right, so this represents a box plot, that is 5-point summary. And if you have to find the, using this box whisker, if you have to find the interquartile range, which is Q3 minus Q1, so you have 9 here and Q1 is 2 here, so 9 minus 2, which is 7, is your IQR, interquartile range. So if you don't have this data, visualizing this box plot, you can find what is the interquartile range. Right, so we will go back to that PPT. Okay, so now for percentile, so the same way, the percentile divide the whole data into 100 parts, and if you want to find a particular percentile, so how you can find, suppose you want to calculate the kth percentile here, so directly we can learn the Excel, in Excel how to calculate here. So we have the data here to find the percentile, right? So percentile, and to calculate the percentile, suppose we want the 55th percentile here. So to find is equal to percentile, we will type, and then you can see it will pop up. If you write just per, it will pop up, and you will just press, select the array and comma and 55 percentile, so 0.55, and close the brackets. So you will get the, what is the 55th percentile. If you have to calculate, suppose 30th percentile, so is equal to percentile, and then select the array and 0.3. So close the bracket, and then that is your 30th percentile. So likewise, you can calculate using the Excel. You can also use the formula to calculate. So kth percentile, it will give you which key, so the data has to be sorted. So if it is a very big data, it is very difficult to calculate it using manually. You can easily calculate it in using Excel. So what you have to do for manually is you will find the index first, which index you need to calculate, then sort the data accordingly and find out what is that position of the index. So here is the description between the percentile and 75th percentile and like that. So here is an example to calculate. So you can write down the whole data into the Excel, and then you can find is equal to 20th percentile. So for that is equal to percentile, and then select the data and comma for 20th, you will calculate the 0.2, 0, and for 55th percentile, so it is 0.55. You will get the value. Now that was the first part, what we described, that is a location, which is quartiles and percentiles. The second one is the center, which is mean, median, mode. So mean, we know, that is finding the average of all, and we can do that by adding all the values divided by number of data set what we have. So suppose I want to calculate the average height of all students. So what I will do is you will add all the height of the students divided by total number of students. You will get the mean. Median, we know how to calculate the median. So if it is the same as second quartile, that is, if your data is odd, then the middle one is your median. If your data is even, then the middle one will be 2. So the average of those two numbers will be the median. Mode, the most frequent value in the data set is a mode. So most number of times it is appeared, then that is your mode. So for example, 222, it is repeated here, so it 2 is the mode. Now any data set can be unimodal, bimodal, or multimodal. Unimodal means only one mode present, bimodal means two mode present, so two numbers repeated the same number of time, and multimodal means more than two. So if the same numbers, three or four numbers are repeating same number of times, then it is called as multimodal. The third measure is skewness, skew to the right and skew to the left. So you can see for this data. So I didn't share you the video here, the slide here. Okay, so the third one is skewness, so skew to the left and skew to the right. So if you see this one here, and it is like this, right? And this one is like this. So this is skewed to the right. So when skewed to the right means mean is greater than median is greater than mode. And when it is skewed to the left means mean is less than median is less than mode. And when all the three are equal, so the graph will be your bell-shaped graph. Right, so this is your perfectly symmetrical when all the three are equal. When mean is less, so then it will be skewed to the left. When mean will be more than the other two, so then it will be skewed to the right. Okay, so now the last one, which is measures of spread. So where we will calculate the range, variance, and standard deviation. So we will do this in Excel. So range is the maximum minus minimum value. Anyway, we know how to calculate it using the Excel, the maximum value and minimum value, and we can find out what is the difference between those two. So that is your range, and I can show you how to calculate the standard deviation and variance in Excel. So now we will calculate, so and we will also see mean, median, mode. So we will write down first what we are going to calculate here: mean, median, and then mode, and then standard deviation. You can also calculate the range, then standard deviation or variance first, and then standard deviation. Right, now for mean, so is equal to average, and open bracket, select the data, and close the bracket. So you will get the mean. Here median is equal to median, open bracket, select the data, you will get the median. So which is should be same as quartiles, right? So it's 7, second quartile. Mode is equal to Now you can see here it is written multimodal, single mode. It is, so I suppose I want multimode. To calculate what are the modes, different modes present, so I want all, and it will give me all the three values, right? So 1 to 10, so 1 is repeated, 2 is repeated, and 10 also is repeated. So it will give me all the three modes here. So I will just shift this one here. Now range is maximum minus minimum. So maximum we select, minus minimum we select, and that will give you the range of the data. Variance is equal to VAR, and then you can select the variance here, var.s, so variance for sample, and we will select the whole data and close the value so you can get the variance. Now if you take the square root of this variance, you will get the standard deviation as well, but we can use the Excel formula std EV. So you can see stdv.s, that is for sample. So we have to calculate it for sample. So for this one, close the data and you will get for sample. You can also calculate it by square root of that. So SQRT. So you can see square root of variance if you take. So that is should also come as the same value. So square root of variance is a standard deviation, and we have a separate formula for standard deviation as well. So this we learned the summary measures, that is we learned about the locations, percentiles and quartiles. We learned about the summary measures, which is mean, median and mode. And we learned about the dispersion, which is range, variance and standard deviation in Excel. Right, so that's it for this video here, and you can practice this one with a question given here. So I will share it with you. You have a question given here which is already solved, and there is another question which is given, which is you need to solve it. So solve it using Excel and see what you are getting, whether you are getting all the answers. So watch the video again. Any questions you can always email back to me. Thank you.